It was a day like any other on Earth, a speck of blue adrift in the cosmic ocean, blissfully unaware of the grand and perilous spectacle brewing just beyond the edges of our solar neighborhood. Across the globe, in observatories perched on mountaintops and nestled in remote deserts, astronomers went about their nightly rituals. They peered through telescopes, charting the familiar waltz of stars, planets, and distant galaxies, their instruments humming with quiet precision. Little did they know, an unseen visitor, a cosmic predator of unimaginable power, was silently slipping into the outskirts of our solar system, its presence cloaked in the vast darkness of space. Then, without fanfare or warning, it revealed itself. A black hole, roughly the size of our moon, materializing just beyond the icy orbit of Pluto. At first it was invisible, a phantom lurking in the void. This enigmatic intruder emitted no light, no blazing signals, no bursts of radiation to betray its arrival. It was a silent specter, detectable only through the subtle ripples it sent through the delicate gravitational tapestry of our solar system. These faint disturbances, like whispers in the cosmic wind, were the first clues that something extraordinary and potentially catastrophic had entered our celestial backyard. The discovery began with a perplexing anomaly. At the Mauna Kea Observatory in Hawaii, astronomers noticed a slight deviation in Pluto's orbit, a wobble so subtle it was initially dismissed as a calibration error. In Chile, the European Southern Observatory's powerful telescopes detected similar irregularities in the paths of distant Kuiper Belt objects. Automated systems, designed to monitor the heavens for the faintest irregularities, soon began sounding alarms. Gravitational wave detectors, sensitive to the tiniest distortions in space-time, picked up signals that defied explanation. Supercomputers, crunching data at a feverish pace, converged on a singular, jaw-dropping conclusion. A black hole, a genuine cosmic titan, had appeared just beyond the fringes of our solar system, closer than any such phenomenon had ever dared to venture. What was this mysterious interloper? Black holes are the universe's ultimate enigmas, regions of space-time so dense that their gravitational grip swallows everything, even light itself. Typically, these celestial behemoths reside in the hearts of galaxies, millions or billions of light-years away, or drift through the desolate voids between stars, far removed from humanity's gaze. But this one was different. It was here, impossibly close, a mere cosmic stone's throw from Earth. Its presence posed an existential question. Was this an unprecedented opportunity to unlock the secrets of the universe, or a harbinger of doom threatening the delicate balance of our solar system? As the news broke, a wave of awe and unease swept across the globe. Observatories redirected their telescopes, scientists canceled vacations, and emergency conferences sprang up overnight. Newsrooms buzzed with frenetic energy, broadcasting updates to a world suddenly transfixed by the cosmos. Governments issued cautious statements, urging calm, while privately grappling with the implications of a force that could, in theory, reshape the very fabric of our existence. On social media, a torrent of reactions poured in, some filled with wonder, others with fear, and many tinged with the wild speculation that flourishes in moments of uncertainty. Amateur astronomers, armed with backyard telescopes, scanned the skies for any hint of the black hole's influence. A star winking out of place, a distortion in the heavens, or a faint gravitational lens bending light in eerie arcs. The black hole's arrival was more than a scientific event. It was a cultural and philosophical earthquake. It forced humanity to confront its place in the universe, to wrestle with the fragility of our world and the audacity of our curiosity. Could Earth withstand the gravitational tug of this cosmic intruder? Would its presence paint our skies with dazzling displays of warped starlight, or plunge us into chaos? Could we, as a species, rise to the challenge of studying a phenomenon that had once been the stuff of equations and imagination, now starkly real and impossibly near? The stakes were staggering. A black hole of this size, so close to our solar system, could exert influences both subtle and catastrophic. It might nudge planets off their orbits, disrupt the delicate dance of moons, or even send comets careening toward the inner solar system. Yet it also offered a once-in-a-millennium chance to study one of the universe's greatest mysteries up close. Theoretical physicists, their minds alight with possibilities, speculated about what we might witness: breathtaking gravitational lensing, where the black hole's immense gravity bends light into surreal cosmic halos, potential jets of energy if it began accreting nearby matter, or even clues to the nature of space-time itself. Every telescope on Earth, from professional arrays to amateur rigs, pivoted toward the coordinates where this silent giant lurked as humanity held its breath, poised on the edge of discovery and dread. This is the story of a black hole at our doorstep, a cosmic event that challenges everything we thought we knew about our place in the universe. In this journey, we'll explore the science behind this enigmatic visitor, unravel the mysteries it holds, and confront the profound questions it raises about our survival, our curiosity, and our destiny. What does it mean when the universe's most unfathomable force arrives uninvited? How will it reshape our skies, our planet, and the very course of human civilization? Join us as we venture to the edge of the event horizon, where science meets wonder, fear meets fascination, and humanity faces its greatest test yet. In the chapters to come, we'll dive deeper into the physics, the possibilities, and the human spirit that dares to stare into the abyss and dream. Stay tuned for Part 2, where we unravel the science of this cosmic intruder and explore what its presence could mean for Earth and beyond. Welcome to the edge of the unknown. Part 2, The Cosmic Grip, unraveling the science of a black hole's power. Gravity, the invisible force that anchors us to Earth, keeps the moon in its gentle orbit, and guides our planet's stately dance around the sun, is the silent architect of our cosmic home. It is familiar, predictable, a comforting constant in our lives. But when a black hole, a celestial titan roughly the size of our moon, yet packing the mass of dozens of Earths, appears just beyond Pluto's orbit, gravity transforms from a gentle guide into an unrelenting overlord. This is no longer the force we know. It is gravity unbound, a cosmic sculptor reshaping the very fabric of our solar system with a quiet, terrifying precision. This black hole, a shadowy intruder lurking in the frigid outer reaches of our celestial neighborhood, begins its influence not with a cataclysmic bang, but with a subtle, insidious whisper. It warps the delicate balance of space-time, sending ripples that unsettle the orderly paths of planets, moons, and distant objects. Pluto's orbit, once a reliable ellipse, begins to waver, its trajectory bending ever so slightly under the black hole's distant pull. Spacecraft, meticulously programmed to follow precise routes, drift off course as if nudged by an unseen hand. Even light itself, light, the universe's swiftest and most untouchable traveler, bends and twists, ensnared by the black hole's immense gravitational embrace. The skies above Earth begin to tell a story of cosmic distortion. Stars, those steadfast beacons of the night, no longer hold their familiar places. Some appear to multiply, their light split into ghostly duplicates. Others stretch into shimmering arcs or halos, as if the heavens themselves have been painted by a surrealist's brush. This is gravitational lensing, the black hole's calling card, a phenomenon where its colossal gravity bends light from distant stars, creating a celestial kaleidoscope that reveals its presence. No longer hidden in the void, the black hole announces itself through these warped visions, transforming our night sky into a canvas of cosmic artistry and unease. At the heart of this spectacle lies the elegant framework of Einstein's general relativity, which explains how a black hole's immense mass curves space-time into a gravitational well so deep that even light cannot escape. Photons, the fastest entities in existence, are forced to follow the contours of this warped reality, curving like ribbons caught in a galactic breeze. But the black hole's influence extends beyond space. It reshapes time itself. Clocks closer to the black hole would tick more slowly compared to those farther away, a phenomenon known as time dilation. This isn't the stuff of science fiction. It's measurable, real, and profound. Satellites in orbit might drift out of sync, their timing systems thrown into chaos. Navigation networks could falter. Even the rhythm of human life, though imperceptibly, might subtly diverge across the solar system, as time itself bends under the black hole's dominion. Yet, for all the answers general relativity provides, this black hole's arrival opens a Pandora's box of deeper, more speculative questions. Could it be more than a gravitational juggernaut? Some physicists, peering into the uncharted territories of string theory and quantum gravity, propose that black holes might be gateways, cosmic tunnels, or wormholes, leading to other universes or distant regions of our own. These ideas, while unproven, are not mere flights of fancy. They grounded in the intricate mathematics of theoretical physics, where the boundaries of possibility are stretched to their limits. Could this black hole, so tantalizingly close, hold the key to unlocking these cosmic mysteries? And what of the singularity, the heart of the black hole, where space-time collapses into a point of infinite density? According to Einstein's equations, it is a place where the laws of physics cease to exist, where space and time dissolve into a realm beyond comprehension. Yet quantum mechanics challenges this notion, suggesting that the singularity might not be a cosmic dead end, but a hidden vault where information is preserved, encoded, or transformed in ways we cannot yet fathom. If humanity could study this black hole up close, it might become a laboratory unlike any other, a window into the fundamental nature of reality itself. Probes could be sent to skirt the event horizon, the invisible boundary beyond which nothing returns, beaming back data from the edge of oblivion. We might witness time slowing to a crawl, observe space-time stretched to its breaking point, and glimpse truths that rewrite our understanding of the universe. This is the promise of the black hole, a scientific frontier of unimaginable potential. It could redefine physics, challenge our theories, and illuminate the deepest secrets of the cosmos. But this promise comes with a shadow. A black hole is not merely a subject of study. It is a predator, its gravity a relentless force that knows no boundaries. If it drifts closer, its influence could grow catastrophic. Planets might wobble in their orbits, their paths destabilized by the black hole's pull. Moons could spiral into their parent worlds or be flung into the void. On Earth, the effects might begin subtly, tides rising higher, oceans stirring under faint gravitational tugs, but the risks would mount. Out in the solar system, an asteroid or comet, nudged ever so slightly by the black hole's influence, could be set on a collision course with Earth, transforming a distant curiosity into an existential threat. This is gravity unleashed, a force both beautiful and terrifying, a cosmic dance of creation and destruction. It is a spectacle that captivates the imagination, stirring both awe and dread as humanity stands at the threshold of the unknown. What will this black hole reveal about the universe? How will it reshape our world, our skies, and our future? And can we harness its secrets before its power reshapes us? Join us in Part 3, where we explore the human response to this cosmic intruder, how scientists, governments, and ordinary people grapple with the awe and terror of a black hole on our doorstep. The journey into the unknown is just beginning, and the stakes have never been higher. Welcome to the edge of the abyss. Part 3. The sky begins to change. In the beginning, the changes are so faint, they slip past the untrained eye, noticed only by those who spend their nights gazing at the stars. Astronomers, their eyes glued to telescopes, murmur about anomalies, stars that seem to flicker out of place, constellations subtly askew, and distant galaxies appearing warped in ways that defy explanation. Then, like a cosmic veil being drawn aside, the heavens begin to transform, revealing the unmistakable hand of the black hole that has taken residence just beyond our solar system. Picture stepping outside on a cool, cloudless night, expecting the familiar tapestry of stars you've known since childhood. Instead, you're met with a sky that feels alien. Orion's belt is distorted, its stars stretched into faint arcs. The Pleiades, once a tight cluster, shimmer as if doubled, their light bent into ghostly echoes. The Milky Way itself, that radiant river of stars, ripples like a silk scarf caught in a celestial wind. This is no illusion. It's gravitational lensing, the black hole's signature writ large across the cosmos. The intruder's immense gravity bends the light of distant stars and galaxies, turning the night sky into a surreal masterpiece, equal parts breathtaking and unsettling. As the black hole draws closer, its influence grows more dramatic. Stars behind it twist into perfect glowing halos, known as Einstein rings, luminous loops of light, warped by gravity into symmetrical splendor. Distant galaxies appear magnified, their shapes contorted into mirrored arcs or smeared into ethereal streaks. The sky becomes a cosmic funhouse, where the laws of optics are rewritten in real time. For the first time in human history, we aren't marveling at artists' renderings or computer simulations. We're witnessing the raw power of physics reshaping the heavens before our eyes. The world takes notice. Satellite imagery floods scientific journals, showing side-by-side comparisons of the sky as it was and as it is now. Social media erupts with photos from amateur astronomers, their grainy snapshots capturing stars that seem to dance or multiply. Science communicators pivot from theoretical discussions to live updates, narrating the unfolding spectacle. In rural areas, far from city lights, people report strange sights. Stars pulsing unnaturally, moons appearing stretched along the horizon, or faint halos encircling distant objects. Even in urban centers, where light pollution once drowned out the cosmos, the black hole's gravitational lensing amplifies starlight, making the night sky blaze with an eerie abundance of stars. But beneath the beauty lies a creeping unease. The sky, once a reliable constant, is now in flux. Navigation systems that rely on precise star positions begin to falter, throwing satellites and spacecraft into disarray. Telescopes, built to peer into the depths of the universe, struggle to calibrate as their reference points shift. Radio signals, once steady, waver as they pass near the black hole, their frequencies bending under its gravitational pull. The heavens are no longer a fixed canvas. They are fluid, alive with invisible currents that hint at the black hole's growing influence. While mainstream scientists scramble to map these changes, deploying satellites and observatories to track the shifting cosmos, fringe theorists sound more alarming notes. Could these visual distortions be the first signs of something far more profound? Some speculate that the black hole's warping of space-time might create stress fractures in the fabric of reality itself, ripples that could destabilize the delicate balance of our universe. These ideas, while speculative, fuel a growing sense of uncertainty. The black hole remains invisible, a void that reveals itself only through its effects, a shadow cast across the stars, a region where light simply vanishes. Each night, that shadow grows. A perfect circle of absence creeps into the sky, a patch where stars and galaxies disappear, swallowed by the black hole's event horizon. It is a wound in the heavens, a silent testament to the intruder's presence. Humanity gazes into this void, and it seems to gaze back, its silence more deafening than any sound. The question is no longer whether the black hole is here. It is. The question is what it will do next, and how its gravitational grip will reshape not just our skies, but our world. As the heavens continue to warp, whispers of a new concern begin to surface. What does this mean for Earth itself? Could the black hole's influence extend beyond the stars, tugging at the delicate orbits that keep our planet in its cosmic dance? The sky may be the first to change, but the true test lies in what comes next. Join us in Part 4, where we explore the chilling possibility of Earth's orbit being altered by the black hole's relentless pull and what that could mean for life on our fragile planet. The cosmos is no longer a distant spectacle. It's a force knocking at our door. Part 4. Earth on the brink, the unraveling of our cosmic orbit. The arrival of a black hole in our solar system marks a turning point for Earth, transforming it from a passive observer into an unwilling participant in a cosmic drama. No longer just a silent speck orbiting the sun, our planet now contends with a new gravitational force, a relentless intruder that threatens to rewrite the rules of our celestial dance. The once predictable rhythm of Earth's journey around the sun, a delicate balance honed over billions of years, begins to falter under the weight of this unseen predator. The black hole's influence creeps in, subtle at first, but with consequences that could reshape life as we know it. In the early stages, the signs are faint, almost imperceptible to the untrained eye. Sensitive instruments detect minute irregularities. The moon's orbit wobbles ever so slightly, deviating from its timeless path. Oceanographers note peculiar shifts in tidal patterns. Ebb and flow no longer align with centuries of data, dismissed initially as statistical noise. Yet, as the black hole draws closer, these anomalies grow undeniable. Earth's orbit, once a stable ellipse carved by the sun's steady gravitational embrace, begins to distort under the influence of a rival force. The black hole's gravity, like an invisible hand, tugs at our planet, pulling it into a precarious new reality. The gravitational pull of a black hole is not a blunt force, but a gradual, insidious slope, a deepening well of space-time that grows steeper with proximity. As Earth navigates this altered gravitational landscape, its orbit stretches and warps. The familiar cadence of seasons, so integral to life, could begin to falter. Summers might linger unnaturally long, or winters could contract into fleeting moments. Days themselves may subtly shift. Earth's rotation, influenced by the competing gravities, could speed up or slow down, imperceptibly at first, but enough to unsettle the delicate balance of our biosphere. The moon, our closest companion, is not spared. Its orbit may grow erratic, swinging farther out or drawing dangerously close, amplifying tidal forces to levels unseen in human history. Coastal cities could face unprecedented flooding, while marine ecosystems struggle to adapt to tides. This orbital instability triggers a cascade of cascading effects that ripple across the planet. Weather systems already prone to chaos, spiral into realms of unpredictability. Hurricanes defy traditional paths, their ferocity and frequency amplified by disrupted atmospheric currents. Jet streams, those high-altitude rivers of air that guide global weather, meander erratically, plunging temperate regions into sudden freezes or scorching heat waves. Migratory animals, guided by instincts honed over millennia, falter as magnetic and gravitational cues fall out of sync. Plants, their blooming cycles tied to the steady rhythm of seasons, flower out of turn, threatening agriculture and ecosystems alike. Nature, so finely tuned to the interplay of sunlight and gravity, descends into a state of disharmony, as if the planet itself is struggling to find its footing in a shifting cosmic landscape. Mainstream astrophysics offers a sobering framework for understanding this scenario. The introduction of a massive gravitational body into a stable system is akin to placing a heavy weight on a delicately balanced mobile. The entire structure must adjust to accommodate the new force, but such adjustments come at a cost. Earth finds itself caught in a gravitational tug-of-war between the Sun, its anchor for eons, and the encroaching black hole. Over years or decades, our orbit could elongate into a stretched ellipse, pulling us farther from or closer to the Sun at different points in our journey. In extreme cases, the orbit could destabilize entirely, threatening to eject Earth from the Sun's habitable zone, or draw it into a fatal spiral toward the black hole's event horizon. Fringe theories push the boundaries of this cosmic nightmare further. What if the black hole's trajectory is not a simple pass through our solar system, but a spiraling descent, drawn inward by the combined mass of the Sun and its planets? In such a scenario, the black hole could gradually usurp the Sun's role as the gravitational center of the system. Planets, including Earth, might be forced into new, unstable orbits around this dark usurper, or worse, pulled inexorably toward its maw. Some models propose a chilling possibility: Earth entering a decaying orbit, spiraling slowly but relentlessly toward the event horizon, where time and space collapse into nothingness. Such a fate would not be swift, but agonizingly gradual, unfolding over years as humanity grapples with a doomed trajectory. Yet, even if Earth avoids a direct plunge into the black hole, the collateral damage is profound. Satellites, reliant on precise orbital mechanics, could drift off course, rendering GPS, communications, and weather forecasting unreliable. Space stations, like fragile outposts in the void, would require constant recalibration to maintain their orbits, straining resources and expertise. Interplanetary missions, once a testament to human ambition, might become impossible as gravitational pathways grow chaotic. Even Earth's magnetic field, generated by the molten iron in its core, could falter if rotational changes disrupt the delicate dynamo effect. A weakened magnetic shield would leave the planet vulnerable to solar winds, bathing the surface in heightened radiation and threatening life at every level. The Sun, once the sole gravitational sovereign of our solar system, now shares its domain with a rival. The interplay of dual gravities reshapes the cosmic architecture. New Lagrange points, regions of gravitational equilibrium, form unpredictably, complicating space navigation. Orbital resonances, the harmonious gravitational relationships that have kept the solar system stable for billions of years, begin to break down. Planets and moons, once synchronized like the gears of a cosmic clock, now tick out of rhythm, their paths growing erratic. The solar system, a marvel of precision for eons, begins to resemble a watch with a broken spring, its once reliable motion descending into chaos. In the most catastrophic scenarios, Earth could be torn from the Sun's habitable zone entirely. If flung outward, our planet might become a frozen wanderer, its oceans icing over and its atmosphere thinning in the cold expanse of space. Alternatively, A tighter orbit could scorch the surface, turning Earth into a blistering wasteland. The most terrifying prospect, however, lies in the possibility of a slow descent toward the black hole's event horizon. Here, the laws of physics as we know them cease to apply. Earth and all its history would be compressed into a singularity, a silent, infinite point where existence itself is erased. Yet, between these extremes lies the more insidious threat, a slow, decades-long unraveling of stability. Earth might not face immediate destruction, but instead endure a prolonged period of environmental and societal collapse. As orbits shift, climates destabilize, and ecosystems falter, humanity would be forced to adapt to a planet increasingly alien to the one we've known. The question looms: does Earth still have a viable path through the cosmos, or are we merely coasting on borrowed momentum, hurtling toward an uncertain fate? Bound to this fragile, spinning world, we can only watch as the gravitational tides reshape our destiny. The black hole, an unyielding force of nature, cares not for our existence. It is a reminder of our place in the universe, small, vulnerable, and subject to forces far beyond our control. As Earth's orbit wavers, humanity stands at the edge of the unknown, wondering whether our planet will find a new equilibrium or spiral into the abyss. Part 5. Beyond the event horizon, portals, consciousness, and the frontiers of reality. As the black hole's gravitational influence tightens its grip on Earth, reshaping our orbit and unsettling the delicate balance of our solar system, the global scientific community races against time. Observatories hum with activity, tracking the intruder's trajectory with unprecedented precision. Supercomputers churn through petabytes of data, modeling the perturbations rippling through our planet's path. Yet, amid the frenetic calculations and urgent conferences, a quieter, more speculative conversation begins to emerge. It echoes through university lecture halls, reverberates in obscure theoretical physics forums, and simmers in the private discussions of visionary thinkers. If a black hole can warp the very fabric of space-time, could it be more than a cosmic abyss? Could it be a gateway, a portal to realms beyond our comprehension? Mainstream astrophysics remains steadfast in its understanding. A black hole is the remnant of a massive star, its core collapsed under crushing gravity into a singularity, a point of infinite density cloaked by an event horizon, the boundary beyond which nothing, not even light, can escape. This is the bedrock of our knowledge, grounded in decades of observations and the rigorous mathematics of general relativity. Yet, at the fringes of scientific thought, where the boundaries of evidence blur into the realm of possibility, bold ideas take root. These fringe theories propose that black holes may not be the final chapters of cosmic stories, but rather doorways, thresholds to other places, other times, or even other realities entirely. Among the most enduring of these ideas is the concept of wormholes, hypothetical tunnels woven through the fabric of space-time. According to Einstein's equations, the same mathematics that describe black holes can, under specific conditions, give rise to these cosmic bridges. A rotating black hole, spinning at immense speeds, might stabilize a wormhole's throat, creating a passage connecting distant regions of our universe, or, more tantalizingly, linking our reality to another entirely. Imagine a shortcut through the cosmos, where light years collapse into mere steps, or a portal to a parallel universe with its own stars, planets, and laws of physics. The presence of a black hole drifting ever closer to Earth raises a thrilling, if untested, possibility. Could this enigmatic object harbor such a pathway? Could its event horizon conceal not just destruction, but a cosmic thoroughfare waiting to be explored. These ideas, while rooted in the mathematics of general relativity, remain speculative, tethered to the realm of theory by the absence of direct evidence. Wormholes require exotic forms of matter with negative energy to remain stable, substances we've yet to observe in nature. Yet, the black hole's approach stirs the imagination, prompting scientists to wonder whether its gravitational distortions might reveal subtle clues about these hypothetical structures. If a wormhole exists, could we detect its influence in the warped orbits of nearby objects? Could we glimpse its shadow in the bending of light? For now, these questions linger at the edge of possibility, but the black hole's proximity offers a rare opportunity to probe the limits of our understanding. Beyond wormholes, even more audacious theories push the boundaries of science into the philosophical and metaphysical. In the esoteric corners of quantum gravity research, a provocative hypothesis suggests that black holes may not only manipulate matter and energy, but also intersect with the nature of consciousness itself. The event horizon, that invisible boundary where space-time collapses, might encode more than just the physical properties of what falls within. Some theorists propose that it could capture the quantum state of intention, the very essence of thought. Could a black hole, in some unfathomable way, serve as a cosmic archive of consciousness? Could it preserve or even amplify the information of sentient minds that encounter it? These ideas, while far from testable, are being explored with mathematical rigor by physicists who dare to bridge the gap between quantum mechanics and the mysteries of the mind. Other fringe theories cast black holes in equally enigmatic roles. Some posit that they are cosmic firewalls, obliterating information to resolve paradoxes in quantum mechanics, ensuring the universe's consistency by erasing contradictory data. Others envision black holes as vast data vaults, where every particle, every photon, and every quantum state that crosses the event horizon leaves behind a trace, a holographic imprint etched onto its surface. Future civilizations, armed with unimaginable technologies, might one day decode these imprints, reconstructing the history of everything consumed by the black hole. Such ideas challenge our understanding of information, entropy, and the fundamental nature of reality itself. Perhaps the most radical notion comes from a growing cadre of thinkers who propose that black holes mark the boundaries of a simulated universe. In this view, our reality is a sophisticated computational construct, and black holes are its edges, glitches in the code where the simulation's rules break down. Their extreme gravitational effects, their distortion of time and space, might be the hallmarks of a program reaching its limits, unable to render the physics beyond a certain point. The black hole's approach forces us to confront a profound question. Are we witnessing a natural phenomenon, or are we brushing against the seams of a constructed reality, where the universe's programming reveals its constraints? These fringe theories, while far from the mainstream, embody the restless curiosity that drives human inquiry. They ask not only what a black hole is, but what it means for our planet, our existence, and our place in the cosmos. The black hole now looming near Earth is both a threat and an opportunity. It could spell destruction, unraveling the delicate gravitational balance that sustains life. Or it might be a messenger, carrying truths about the universe that we've only begun to imagine. It challenges us to look beyond the immediate peril and consider the deeper implications of its presence. In laboratories and observatories, scientists continue their tireless work, measuring the black hole's trajectory, modeling its gravitational effects, and predicting its impact on Earth's orbit. But in quieter spaces, illuminated by the soft glow of computer screens, marked by whiteboards covered in equations and diagrams, a different kind of exploration unfolds. Here, Researchers and dreamers alike peer into the abyss, not just to understand the physics of black holes, but to probe the very nature of existence. What lies beyond the event horizon? Is it a void of nothingness, a portal to another reality, or a mirror reflecting the limits of our understanding? As the black hole draws closer, its shadow looms over our planet, both literal and metaphorical. It is a monster, yes, but also a mystery, an enigma that invites us to question the fabric of reality itself. If a doorway exists within its depths, will humanity find the courage to approach it? If truths lie hidden behind gravity's veil, will we be ready to uncover them? And if the black hole is indeed a portal, whether to another universe, a higher state of consciousness, or the edges of a simulated cosmos, will we dare to step through? Part 6. Facing the Abyss. Can humanity survive or find a way to escape? As the black hole's gravitational influence intensifies, warping the familiar patterns of stars and casting an eerie distortion across the night sky, the questions gripping humanity shift from the theoretical to the existential. The cosmic threat is no longer a distant curiosity, but an immediate crisis, its shadow looming over every facet of life on Earth. The perturbations in our orbit, the erratic tides, and the growing chaos in our climate are undeniable. The question on every mind, spoken in hushed tones in homes, debated in crowded laboratories, and broadcast across global networks, is stark and urgent. Can humanity survive this? Can Earth endure the black hole's passage, or is there a way to escape its grasp? The first instinct is to protect what we have, to fortify our planet against the encroaching menace. Scientists and engineers worldwide mobilize with unprecedented urgency, their efforts synchronized in a global push to understand and counter the black hole's effects. Observatories from every continent turn their lenses skyward, forming a planetary network of telescopes that track the intruder's trajectory with pinpoint precision. Supercomputers hum around the clock, processing torrents of data to model the black hole's path and predict its impact on Earth's orbit. If it maintains a distant orbit, its influence might remain manageable, a mere ripple in the cosmic fabric. But if it drifts closer, even by a fraction of an astronomical unit, the consequences could be catastrophic. Space agencies, once siloed by national interests, forge alliances, sharing resources and expertise. Satellites are recalibrated to withstand gravitational disruptions. Data streams in ceaselessly, and predictive models are refined by the hour. Each update a desperate attempt to chart a path through the crisis. The potential outcomes are grim, each scenario more harrowing than the last. In one, the black hole's gravity nudges Earth into an unstable orbit, stretching our elliptical path until we drift too far from the sun, plunging the planet into a frozen wasteland where ice encases oceans and life struggles to endure. In another, tidal forces, amplified beyond anything in Earth's history, unleash tectonic havoc. Earthquakes rumble with unprecedented ferocity. Supervolcanoes awaken, spewing ash that chokes the skies, and the atmosphere itself could begin to erode under relentless gravitational stress. The most terrifying possibility looms in the background. Earth spirals toward the black hole's event horizon, heading for a singularity where time, space, and existence collapse. Mainstream science offers no easy solutions, no deus ex machina to avert disaster. Our technology, remarkable though it is, lacks the power to redirect an entire planet or shield it from cosmic forces. Yet, the absence of miracles does not deter the brightest minds from dreaming up audacious plans. A fringe coalition of aerospace engineers and theoretical physicists dusts off a radical concept: planetary propulsion. The idea, once relegated to the edges of science fiction, proposes embedding colossal nuclear-powered thrusters into Earth's crust to slowly, over decades, nudge the planet onto a safer trajectory. Blueprints exist, buried in academic archives, intricate designs for engines that could harness the energy of thousands of nuclear warheads to shift Earth's course. The challenges are staggering. The energy requirements are astronomical, the engineering untested, and the timeline daunting. Yet, with extinction on the horizon, these once fantastical proposals are revisited with deadly seriousness, their feasibility debated in urgent, high-stakes forums. Others argue that survival lies not in saving the planet, but in abandoning it. Visionaries propose interstellar arcs, massive generation ships designed to carry humanity's remnants to distant stars. These vessels, powered by nuclear pulse propulsion, advanced ion drives, or theoretical light sails, would be humanity's lifeboats in the cosmic void. The nearest candidate, Proxima Centauri, lies 4 light-years away, a journey that would stretch across generations. Humanity has never sent a person beyond the moon, and the technological hurdles are immense, building self-sustaining ecosystems, shielding passengers from cosmic radiation, and navigating uncharted interstellar space. Time, as always, is the greatest adversary. Even with global resources poured into the effort, constructing such ships within a viable time frame seems a near impossible feat. Closer to home, discussions turn to alternative refuges. Underground bunkers, carved deep into Earth's crust, could shield small populations from surface chaos. Orbital habitats, self-contained space stations, offer another possibility, though their fragility and reliance on Earth for supplies make them a temporary solution at best. The Moon and Mars emerge as potential outposts, but both are hostile worlds. Terraforming remains a distant dream, requiring centuries of effort, and existing colonies are little more than experimental outposts, far from self-sufficiency. Earth, for all its growing instability, remains the only world humanity has truly mastered, a bittersweet truth as the black hole's influence grows. Beyond the technological challenges lies a deeper, more profound hurdle, the psychological toll of facing an existential threat. How does a civilization maintain cohesion when the sky itself seems to collapse? Societies grapple with fear, uncertainty, and the specter of an uncontrollable fate. Governments struggle to maintain order as panic threatens to unravel social fabrics. Religions adapt, weaving the black hole into their cosmologies. Some see it as divine judgment, others as a test of faith. Philosophers revisit ancient texts, seeking wisdom in the face of oblivion. Artists, too, turn their gaze upward, producing works that capture the terror and awe of a universe in flux. Paintings of distorted skies, music that echoes the hum of gravity, stories that blend despair with defiance. The black hole becomes a mirror, reflecting not just the physics of the cosmos, but the resilience of the human spirit. Yet, amid the fear, a stubborn hope persists. Across cultures and borders, a shared determination takes hold. If this is humanity's crucible, we will face it with eyes wide open. Scientists share data freely, transcending old rivalries. Nations pool resources, forging alliances born of necessity. Ordinary people, too, find purpose in small acts of defiance, planting trees for a future they may not see, writing books to preserve their stories, raising children to carry forward humanity's legacy, and building spacecraft to reach for the stars. These acts are not born of certainty, but of a refusal to surrender to despair. The black hole, for all its terror, becomes a catalyst for unity, a reminder of what humanity can achieve when pushed to the brink. Then, in a moment that feels both miraculous and fragile, new calculations emerge. Weeks into the escalating crisis, Astronomers announce a shift in the black hole's trajectory. It is not on a collision course after all. Its path arcs subtly outward, passing dangerously close to Earth, but missing by the slimmest of cosmic margins. The news ripples across the globe, igniting a collective exhale. The danger has not vanished. The black hole's gravitational wake will still disrupt orbits, climates, and ecosystems. But the immediate threat of annihilation recedes. Humanity has been granted a reprieve, a fleeting chance to regroup and rebuild. The world that emerges from this brush with oblivion is forever changed. The crisis sparks a renaissance in technology, with space programs receiving unprecedented global funding. Innovations in propulsion, energy, and habitat design accelerate, driven by the urgency of survival. The unity forged in fear begins to take root as purpose, as nations and individuals alike recognize the fragility of our place in the cosmos. Humanity, scarred but unbroken, carries the weight of its near extinction, a collective memory etched into our culture and consciousness. Yet, no one forgets the dark specter that passed through the sky. Its presence lingers, a reminder of the universe's indifference and power. Observatories remain vigilant, their telescopes trained on the heavens. Scientists continue their work, knowing that the cosmos holds no guarantees. And humanity, forever altered, watches the stars, not just with fear, but with a newfound resolve to endure, to explore, and to defy the abyss. Conclusion. A mirror to eternity, humanity's dance with the cosmos. For millennia, humanity has gazed at the stars, finding in their distant light a source of wonder, guidance, and solace. They have been our anchors, fixed points in a turbulent world, shaping our calendars, weaving our myths, and reminding us of our fleeting existence within the vastness of the universe. But when that vastness turns its unyielding gaze upon us, when the silent gravity of a black hole brushes against our fragile world, we are forced to confront not just the cosmos, but ourselves. The black hole that passed perilously close to Earth did not leave scars of fire or ruin. Instead, it left something far more profound: a question, a silence, a fracture in our certainty. It became a mirror, reflecting our vulnerability, our resilience, and our insatiable hunger to understand the unknown. This cosmic intruder, with its relentless pull and enigmatic presence, was more than a threat. It was a revelation. It stripped away the illusion of Earth's invincibility, exposing the delicate balance that sustains our existence. The black hole's passage, though it spared us from annihilation, reshaped our perspective. It was not merely a force of destruction, but a symbol of the universe's indifferent beauty, a beauty that does not bend to our desires or fears, but unfolds according to its own inscrutable design. And yet, we, fragile beings of carbon and curiosity, dared to meet its challenge, to question its nature, and to seek meaning in its shadow. In the face of potential oblivion, humanity revealed its true strength. We did not cower or collapse under the weight of cosmic dread. Instead, we rose, united, determined, and relentless. Scientists across the globe shared data with unprecedented openness, their instruments trained on the heavens in a collective quest for answers. Engineers revived audacious dreams of planetary propulsion and interstellar arcs, pushing the boundaries of what we believe is possible. Nations set aside rivalries, forging alliances born of necessity, but tempered by a shared vision of survival. Ordinary people, too, found purpose in the crisis, planting seeds for a future they might not witness, writing stories to preserve their truths, and raising children to inherit a world forever changed. The black hole, for all its terror, became a catalyst, igniting a spark of unity and ambition that burned brighter than the stars themselves. When the calculations arrived, revealing that the black hole's trajectory would spare Earth by the narrowest of margins, the world exhaled. The immediate threat receded, but its impact lingered. The skies, once a backdrop to our lives, became a living tapestry, an ocean of mystery, vast and unpredictable, sometimes gazing back with a silent intensity that humbles us. The black hole's passage left no physical wreckage, but it reshaped our collective psyche. It taught us that survival is not guaranteed, that our place in the cosmos is fragile, and that our existence is a fleeting note in an infinite symphony. Yet, it also showed us our capacity to endure, to adapt, and to dream beyond the limits of our world. In the aftermath, humanity did not retreat into complacency. The crisis became a crucible, forging a new era of exploration and discovery. Telescopes multiplied, their lenses sharper, and their reach deeper, scanning the heavens for the next shadow that might drift our way. Space programs, once constrained by budgets and borders, flourished under global cooperation, fueled by a shared sense of purpose. New technologies emerged, propulsion systems, orbital habitats, and the seeds of interplanetary colonies, each a testament to humanity's refusal to be bound by the gravity of fear. Children born in the wake of the black hole grew up with a new understanding of the cosmos, not as a distant spectacle, but as a dynamic frontier, alive with possibility and peril. They learned to see the sky not as a ceiling, but as a threshold, an invitation to explore, to question, and to reach for what lies beyond. The black hole's legacy is one of paradox. It was both a harbinger of destruction and a beacon of transformation. It reminded us that the universe owes us nothing, no safety, no certainty, no answers. Yet, in that very indifference lies its greatest gift, the challenge to create our own meaning, to carve our own path through the stars. Somewhere in the uncharted depths of the cosmos, another black hole drifts, its gravity bending light and time. Another silence waits, pulsing with mysteries we cannot yet fathom. The universe is vast, and its secrets are many, but we are no longer mere passengers. We are explorers, driven by a relentless curiosity and an unyielding will to endure. This is the forgotten cosmos, a realm of wonder and terror, where the boundaries of reality blur and the unknown beckons. It is not the end of our story, but the beginning of a new chapter. As we continue to watch the skies, to build, to dream, and to reach, we become more than survivors. We become stewards of a legacy that stretches beyond our planet, beyond our time, and into the infinite. The black hole was our mirror, reflecting both our fragility and our fire. And in its shadow, we found not just the will to live, but the courage to explore eternity. So we press forward, eyes lifted to the stars, hearts alight with purpose. The cosmos waits, vast and untamed, and we, undaunted, step into its embrace.
In 1915, Albert Einstein changed our understanding of the universe, not by discovering new particles or building new machines, but through the power of thought. His theory of general relativity revealed that space and time are not separate entities, but are woven together into a single fabric, space-time. And that fabric, like cloth pulled and warped by weight, is distorted by mass. To understand how black holes bend time, one must first grasp a deceptively simple truth. Time does not pass at the same rate everywhere. It is elastic. It stretches and compresses depending on how fast one moves or how close one is to a source of gravity. Einstein's famous thought experiments often involved elevators, trains, and light beams. One in particular helps us here. Imagine two observers, one standing on Earth, the other floating far from any planet or star. If both set their watches at the same moment and one travels near a massive object like a black hole, they would discover something strange upon reuniting. The traveler's watch ticks more slowly. They have aged less. This effect is called gravitational time dilation, and it's been confirmed through both theory and experiment. Atomic clocks placed at different altitudes on Earth tick at slightly different rates. GPS satellites must constantly adjust their timekeeping to account for the difference in gravity between orbit and the ground. These are small differences, but near a black hole, the shift becomes staggering. Mainstream physics holds that the stronger the gravitational pull, the slower time flows relative to a distant observer. As one approaches the event horizon, the boundary around a black hole where escape becomes impossible, time begins to behave unusually. An external observer watching someone fall toward a black hole would never see them cross the event horizon. Instead, the person would appear to slow down endlessly, frozen in place.